I'm Grace. Today, we're looking into a fundamental aspect of secondary mathematics that forms the foundation of many mathematical concepts: proportional reasoning. Proportional reasoning is an important topic as it has application in various aspects of our daily lives. Think about using scale factors for resizing images, creating scale diagrams, reading maps accurately, understanding ratios, both parts and wholes, and even solving problems involving direct and inverse proportions. It's an essential skill that gives students the skills to tackle real-world problems. Before we investigate teaching strategies for proportional reasoning, let's address a common misconception in ratio: the difference between 2 out of 3 and 2 for every 3. Visual aids like bar models and representations can help us distinguish between these two concepts. 2 out of 3 is a part to whole model, where 2 represents the part and 3 the whole. In contrast, 2 for every 3 represents a part-part model, signifying a whole of 5. Now, we will explore key representations in proportional reasoning to bridge the gap between concrete and abstract concepts. These representations use the keywords of ratios, equal parts, for every, proportions, and relationships, which provide a solid foundation for proportional reasoning. Let's start by introducing proportional reasoning using a simple statement. For every 2 yellow, there are 3 red. We'll use concrete materials like counters or blocks, ensuring that they are all the same size for a hands-on experience. Correctly representing the ratio 2 yellow to 3 red is crucial in developing a deep understanding. The correct representation is to ensure all of the parts are of equal size. They can be represented in one bar, which is useful to represent the total of 5 parts, or stacked to distinguish between the 2 variables. The main misconception to highlight here is representing the parts with unequal size. Ratio and proportional thinking relies on the understanding of relative proportion. During the lesson resources, we'll ask questions like, how many parts in total make up the whole? And how many parts are red? And how many parts are yellow? This connects proportional reasoning to the part-whole model and fractions. In this example, when looking at the red parts, there are 2 parts out of 5, which is a fraction of 2/5. The yellow parts are 3 parts out of 5, which is 3/5. These parts will add up to the whole of 5/5. Emphasise to students that the ratio doesn't dictate specific quantities of yellow or red, but represents their proportion. This means you can multiply each part by the same amount, maintaining the ratio. Double number lines are also a useful representation as it encourages students to focus on the parts. It is important here to emphasise to students that the scale for each part is different. For example, with a ratio of red to yellow in the ratio 2 to 3, each time the red is increased by 2, the yellow is increased by 3. So, when you multiply each variable, they will multiply by the same variable. When students become more fluent and master the skills of ratio, they will be able to calculate the direct multiplier or scale factor between the yellow and the red by multiplying by 1.5. They will be able to see that the yellow value is always 1.5 times larger than the red. At this stage, you will introduce the ratio symbol and link this back to the representations. The important concept here is the order of the items and the language of each part, with each part being a variable. Discuss the differences between the two with the ratio in the order green to yellow. What is the difference between the ratio of green to yellow of 3 to every 1 and 1 to every 3? When writing ratios, it is obviously always important to name the variable assigned to each number to ensure that the order is correct. Green to yellow, 3 to 1. This ratio means there are 4 parts in total. Green is 3/4 of the total, and yellow is 1/4 of the total. It is useful at this stage to get students to engage in matching activities as they build their understanding and links between the words, the ratio, fractions, and the representation. Let's move on to another key concept of proportional reasoning, the unitary method. This involves finding the value or quantity of one part and then scaling back up to the required number of parts. Consider the following examples. 5 lollies costs $4.50. Represent this on a bar model, linking it to a concrete model. When discussing the model, refer to the whole representing the $4.50 and the parts representing single lollies. Then ask students how to calculate the price of 1 lolly. At this stage, get students to use a calculator to solve these problems, because the focus of the learning intention here is to use a multiplicative change, not multiply numbers with non-calculator methods. Once students know how to calculate the cost of 1 lolly, ask them to scale up to find the cost of 10 lollies, 8 lollies, and 9 lollies. This can then be extended to a more abstract model, with a ratio table using action arrows on either side to multiply or divide. As students develop mastery with this representation, they will be able to see links between the steps and not always have to apply the unitary method. For example, students will be able to see the link between 5 lollies and 10 lollies, and will be flexible enough to then see the need to use the unitary method step when finding the cost of 8 or 9 lollies. The action arrows highlighted in the previous example are a useful strategy for students to use. Use language such as, what do I need to multiply 2 by to get to 4? Therefore, what do I need to multiply 10 by for it to be in the same proportion? This emphasises that students are not adding or subtracting, but scaling up or down using multiplication or division. This skill will be transferable to other areas such as equivalent ratios, equivalent fractions, and scales. Consider the following example. Nina and George share $36 in the ratio 4 to every 5. How much will Nina and George each receive? The ratio of 4 to 5 has 9 parts, but we want to share $36. The multiplier from 9 to 36 is 4, so we multiply all parts by 4 to get $16 for Nina and $20 for George. Proportional reasoning is a critical skill for our students, with applications far beyond the classroom. By using these concrete, pictorial, and abstract representations, along with engaging activities and examples, we can equip our students with the skills they need to excel in proportional reasoning.